There was no center given. Okay? There was no center given. Therefore, we can't use any one of the center theorems. Alright? Then you must also check if there's a diameter. Please, here, we are not told that there's a diameter. So, SQ is not a diameter. You have to prove that it's a diameter first. If you think that it's a diameter, then prove first that it's a diameter. Okay? But it is not a diameter. Okay? And also, it looks like it's a diameter, but it's not a diameter. Okay? So, you might have to prove that this angle here, that is SRQ, is 90 degrees. Then you can say, therefore, SQ is the what? It's a diameter. Do you hear what I'm saying? Yeah, don't make the assumption that, oh, it looks like a diameter, therefore I'm going to work with it as the diameter. It's not a diameter. Prove that it is. So to prove that it is, then you have to prove that this whole angle there is equal to 90 degrees. Okay? So you might have to think about ways, but that will make the question more complicated. Alright? So, let's consider what he said as method 1, because that's the easiest way. The objective is just to prove that Q2 is equal to W1. That's the objective. If you prove that those two angles are equal, then you can say, therefore, KQ is a tangent. You're using converse tan-chord theorem. Right? So let's do that. So first thing, if you look at the question carefully, right? We have got a butterfly there. We have got a butterfly. Always, when you have got diagrams, look for butterflies as well. That's theorem 4. Okay? If a diagram is very complex, check for cyclic quads, check for butterflies. Because remember, a butterfly is also a cyclic quad, right? Make sure you check tangents and so on. So this is a butterfly here. So it makes things very easy. W1 is equal to angle S. Okay? So we can start by writing that down. So for 4.1, we say W1 is equal to angle S. And our reason there will be theorem 4, angles in the same segment. Okay, angles in the same segment. Alright? Then, since we are given two lines that are parallel, it means somehow we have to use those lines. Whenever you are given lines that are parallel in a question, it means somehow you have to use that. So you can see here that RL is a transversal. Okay, or rather I would say SQ is a transversal because TQ is parallel to SP. Therefore, angle S is equal to angle Q2. So here, right here, Q2 is equal to angle S. The reason alternate angles. Then you state the lines that are parallel, so that PS is parallel to QT. Okay? Now, because we have got S and S, it means the left-hand side are equal, so we can say, therefore, W1 is equal to Q2. Please, you don't have to give a reason there. That's a conclusion based on the two statements. There's no reason that you have to give. Then, you are going to answer now the question. Therefore, we say, therefore, KQ is a tangent. Okay? Our reason will be converse tan-chord theorem. Okay? Please take note that this word here, converse, is very important. Because we are trying to prove that a line is a tangent. Okay? So this is how you could have approached the question. Okay, this could be, I would say, method 1. Now, is there another way besides this to prove that W1 is equal to Q2? Is there another way? Is there another way? Don't rush to just say no. there anybody who saw something different? Is there anyone who saw something very different from what he saw? Okay. So those of you who did this way, that's the way that you saw. But it could be possible as well to get to this same conclusion that W1 is not Q2. But this will be the easiest way. But now it depends on whether you saw it. Because remember, when you're answering geometry, a diagram like this here, you can only answer the question based on what you are seeing. So if you don't see something, then you might end up having issues. Then, but who saw something else? Yes. How to prove what? Can you speak up, please? Can you speak up, please? Yeah. Okay. First thing, you need to know that any triangle has got can be inserted into a circle. That means the three vertices can be of the circumference for any triangle. It's not true for quadrilaterals, but for triangles, I can draw a circle passing through those. Okay? Now, this question here is mainly on proving that KQ is a tangent to a circle which passes through the point L, Q, and W. That's what the question is asking. So, because we have got the line KQ here, the angle Q2 must be equal to Q1 based on the converse of theorem 9. Okay? Which is what has been proven here. You have to know the objective. Okay? You also have to know what you are trying to prove. So here, you need to know the objective is to prove that KQ is a tangent. But how do you get there? Prove that W1 is not Q2. Now, you can't use the converse of theorem 7 here. Okay? You can't use the converse of theorem 7. Yeah. There's no way that you can use the converse. Because there are only two ways of proving that a line is a tangent. All right. I think it could be possible to do it in a different way from how these two or another person saw it based on this. This is the easiest way, which you can easily see. But let's move on to the next page. I'll try to show you a second method. Right. So we are still doing that. 4.1. All right. If you look at it, right, we are told that SR is equal to TW, right? Those are chords, right? Remember I told you there are three corollaries on equal chords being equal to equal angles at the circumference and equal angles at the center. So what that means is that angle Q1 is equal to that angle Q what? That will be Q3. So Q1 and Q3, they are equal based on equal chords being equal, equal chords subtending equal angles at the circumference. Do you remember that? Okay, so we have got a chord TW, we've got a chord SR. Both subtend angles at the circumference. So Q1 is equal to Q3. All right? Then, remember, the objective is to get to a point where you say Q2 is equal to W1. That's the objective. Okay? Then, if you look at this angle here, right, obviously, it's gonna be equal to that whole angle. Okay, let me just use a different color here. I think you know this, or you can see it, that because of the butterfly here, we just illustrate that. Okay, this whole angle here, that is R3, no. R3 is equal to Q1 plus Q2. Do you see that? Huh? And then we can also prove that Q1 is equal to angle S. Do you also see that? Okay, in fact we have mentioned before that Q2 is equal to angle S. But here I want to show you that we can use a different route to prove that W2 is equal to what? To Q1. Right? So I'm gonna start by saying this is 4.1. So first thing I'll say Q1 is equal to Q2. And my reason is going to be equal chords, equal angles. All right? Are you following that? Now, we also have another butterfly, but I'm not sure. Here you might have to see it properly. Okay, let me use the blue pen. So this is also a butterfly. Let me draw it that way. This is a butterfly. Am I right to say that? Huh? That's also a butterfly. So what that means is that W1 is going to be equal to W1 is going to be equal to Q1. Okay, let me see that. Okay, it's actually W2 is going to be equal to that whole angle there. That is Q2 plus Q3. Okay, so I can say W1 is equal to Q2 plus Q3. And the reason will be angles in the same segment. Okay? Do you see that? Huh? Okay. Already, we also have a tangent. That tangent there. Okay, which means Q4 is going to be equal to angle S. Q4 is going to be equal to angle S. And now let me see how I can carry on there. Okay. Angle T. This whole angle here is equal to it's equal to there is no name for this. I think it's R2, right? Okay. That's R2. Okay. So let me write here and say angle T is equal to R2. Then my reason will be angles in the same segment. Okay, angles in the same segment. Right? Then now if you look at triangle, let's say triangle TWQ. I know this angle, I know that angle, plus this whole angle here. They give me 180 degrees. Okay? Okay, please be aware that this method which I'm showing you now, it's a longer method. The first one is the easiest. But what if you didn't see it? What if you didn't see it? So I'll say in triangle TWQ, okay? In triangle TWQ, angle T plus angle W plus angle, now that will be Q1, right? Times Q1, this will give me what? 180 degrees. Are you following that? Does this make sense? Right, let's substitute here and see what you get. So if I substitute, I don't need the substitution materials yet, but this W here, it's equal to W1 plus W2. Okay, so let me carry on. to the next page. I'm going to create another equation. Right, the next equation now, I'm going to use triangle RWQ. Okay? Now, in that triangle, it's important for you to know that angle Q4 is equal to angle S. At the same time, angle Q2 is equal to angle S. So I think I need to write that down. Okay? Okay, let me write that down. So I'll say angle S is equal to Q2. Also, angle Q2, or rather, it's angle S. So this is Q2. Okay, I'll give my reason here, alternate angles. Then, my two lines that are parallel is going to be TQ is parallel to SP. TQ is parallel to PS. Also, please remember this is Q2. Angle S is equal to Q4. Okay? So I can give my reason here as tan chord theorem. Okay? Then, in triangle, if you look at triangle RWQ, okay, RWQ, right? If I add R1, actually that would be R2 plus W1 plus this whole angle Q1, Q2, Q3. Okay? I'll end up getting 180. Do you see that? Am I talking to myself now? Right? So W, yeah, that would be W1. So W1 plus R2, okay, plus R2 plus Q1 plus Q2 plus Q3. This will give me what? 180. Right? Please, I need to write my reason here. Sum of angles in a triangle. If I was teaching another class, I was not going to bother myself here. Right? But because of the nature of this class, I need to show you that if you don't see one way, you need to figure out what? Another way. Because some of you, probably you got stuck because you didn't see what he saw. Then you gave up. Right? So this will be sum of angles in a triangle. Remember, what is the objective? Who can remind us about the objective? What is the objective?
To find to prove that Q is that.
Yes, to prove that Q2 is equal to W1. That's the objective. Right? So, let's get on. Now, you see this equation here. Can I have your attention? This equation here. I'm going to write this equation and write as T plus W1 plus W2 plus Q1 is equal to the left-hand side of the second one. Right? So, I can write T plus W1 plus W2 plus what? Q1 is equal to. You see this equation. So we have W1 plus R2 plus Q1 plus Q2 plus Q3. Are you following what I'm doing here? Now, are you aware that some of the angles here they are equal? Like T is equal to R2. So this cancels with that. Look at the diagram. Look at the diagram. Right? Then this W1 and that W1, they are also equal there, so they can cancel out. Are you following that? Right? And we have got this Q1 here and that Q1, they also cancel out. So the equation is getting simpler and what? And simpler. Then we are left with that. Okay? So what are we left with? W2. Okay, but I want to prove that W1 is equal to Q2. So in that case now, I think, okay, please just bear with me. I rushed to cancel this two. Let me, yeah, because, okay, I rushed to cancel those two. Let's go back and not cancel, because I need to prove that this W1 is equal to what? Q2. So I can cancel this Q1 and that Q1. That's fine. Alright? Then these two, Q2 and Q3, if I go back here, if I go back there, okay? Do you see where Q2 is? We have got Q3 there. But do you agree with me that Q3 is equal to Q1? Do you agree with me with that, on that? Q3 is equal to what? Yes. Is equal to Q1. Right? So if Q3 is equal to Q1, it means this Q3, right, is equal to Q1. It means I can replace it. So I've got W1 here. Okay, let's see.
So why are they equal?
Okay, W is equal to angle S. But S is equal to Q2 as well. Alright, is there something that I'm missing here? W2.
So there's an answer that's 4 lines long. Let's just go with that.
Alright, I need to prove that this Q1, this W1 is equal to Q2. So what that means is if I add W1 and Q3, I must get W2. Okay, I think, let's see if that's possible. So this whole angle here is equal to that. It makes sense. And can I have your attention, please? Can you please be part of the lesson? There's something that I'm missing here. Because R2 is equal to that, they cancel out Q1 and Q1. Okay, I need to prove that this is equal to that. Huh? I don't want them to cancel because remember the objective is to get to W1 equal to Q2. Okay. Q1 and Q3. Now the thing is, we have to eliminate the Q. Okay. Can you wait? Can I have your attention? Do you agree with me that Q1 and Q3 they are equal? Yes. So they can cancel out. Yes. Yeah, but then okay, if I cancel out this Q1 and that Q3, I'm gonna be left with Q1 plus Q2. Q1 plus Q2 and this W2. As it is Q1 plus Q2. Okay, listen. Please, here I wrote Q2 by mistake, supposed to be Q3. W1 equal Q2 plus Q3. No. Hey, can I have your attention? This is supposed to be W2 is equal to Q2 plus Q3 because hey, can I have your attention? This is Q2. It's equal to that whole angle there. The angles in the same segment. So I need to correct that. So this is supposed to be Q2. W2 is equal to Q2 plus Q3. Check again on the diagram. Right? So let me go back. So W2 is equal to Q2 plus Q3. It won't work. Alright. Okay, it won't work because everything on the left and the right will end up cancelling out. It won't work. Right? So this method it won't work. Because these two are equivalent to that. So it won't work. It won't work. Alright, let's abandon this. So it means that the best approach is this. Alright? Okay, let's carry on. No, I've got the diagram. Okay, can I have your attention? Let's carry on now. The next thing is to prove that R1 is equal to L3. Okay? Now, L3 is here. This is L4, L3 is there. Okay, I think I just need to put a new diagram, nice diagram. Let me put a new diagram. Alright. So the next question now, we need to prove that R1 is equal to L3. So L3 is this angle here, right? This angle, it's that angle there. It's equal to R1. Okay? So I'm not sure how you might have done that question. Can someone tell us how you might have approached that question? Okay, how did you do it? Huh? How did you do that? Okay, I'll just show you how I'll do it. So this is L3 is equal to W1 plus Q1. That's exterior angle of a triangle. Okay? Are you following there? Right? And then R1 is equal to Q2 plus Q3 because of alternate angles. So this will be equal to Q2 plus Q3. Okay? But then, is there a relationship between W1 and Q2? Right? But W1 is equal to what? To Q2. This was proved in what? In 4.1. Okay? We proved that. Also, is there a relationship between Q1 and Q3? The answer is a big yes. Okay? Remember, I proved already that Q3 is equal to Q1. It's because of equal chords subtending equal angles. Do you remember that? Right? But here, just to remind some of you, I'll just write here, but Q1 is equal to Q3. My reason here will be equal chords, equal angles. Equal chords, equal angles. Okay? Now, since I've got those two, then I can say, therefore, let me go to the next page. Or I can squeeze it on top here. Therefore, just give me a few seconds. Therefore, L3 is equal to, L3 is going to be equal to, wait. We need to substitute whatever we wrote here. Okay? Until we have got the right hand side here being equal to that right hand side. So if I decide to eliminate, means I can say W1 plus Q1, okay? And R, that's angle R1 is equal to Q1. So this is W1, okay? Because Q2 is equal to W1, remember, right? And then Q1 is equal to Q3, so I can put Q1 there. Therefore, L3 is equal to R1. Okay, all right, we'll carry on tomorrow.